Hello learners! Welcome to our math lesson made easy with Teacher Cory. Our lesson for today is all about systems of linear equations in two variables. At the end of the session, you are expected to categorize when a given system of linear equation in two variables has graphs that are parallel, intersecting, and coinciding. For the review time, let us recall the lesson that has been discussed. Graph the given pair of equations. Number 1, 3x plus y equals 5 and 2x plus y equals 3. Number 2, 3x minus y equals 4 and y equals 3x plus 2. And for number 3, x plus 3y is equal to 6 and 2x plus 6y is equal to 12. There are different ways on how to graph the given pair of equations, but for today, we're going to use slope and a point. So we need the slope-intercept form. Rewriting the given 3x plus y is equal to 5, that will become y is equal to negative 3x plus 5. The slope will now be negative 3. And the y-intercept is 5. And for the second equation, we have 2x plus y is equal to 3. Writing the equation, we have y is equal to negative 2x plus 3. Again, using the slope-intercept form, y is equal to mx plus b, the slope will now be negative 2 and the y-intercept is positive 3. Since we already have the value of the slope and the y-intercept, we are now ready to graph the given equations. For 3x plus y equals 5, the y-intercept is at positive 5. So the point is located at 0, 5, and that is along the y-axis. To find the other pair, we have to take a look at the slope, which is negative 3, or it can be written as negative 3 over 1. And the rise is negative 3, so we have to count 3 downward. That is 1, 2, 3. And for the run, we have positive 1. And we have to count 1 to the right. That is now the point which is located at 1, 2. Connecting the 2 points, we have now the graph of 3x plus y is equal to 5. For the second given, we have 2x plus y is equal to 3. The y-intercept is at positive 3. Therefore, the point is located at 0, 3, which is along the y-axis. To find the other pair of points, we have to consider the slope, which is negative 2 or negative 2 over 1. Again, the rise is negative 2, and that is, we have to count 2 downward from the given point, which is 0, 3. 1, 2. And then, the run is positive 1. Okay. And the location of the point is at 1, 1. Connecting the point, we have now the graph of 2x plus y is equal to 3. The second pair of equation is 3x minus y is equal to 4 and y is equal to 3x plus 2. Again, we have to rewrite the given equation to find the slope and the y-intercept. For the first equation, we have 3x minus y equals 4. Rewriting this into the form y equals mx plus b, we have now negative y is equal to negative 3x plus 4. Since y there is negative, we have to multiply both sides of the equation by negative 1. Our equation now will be y is equal to 3x minus 4. and the slope is positive 3. Y-intercept is negative 4. For the second equation, y is equal to 3x plus 2, that is in the form y is equal to mx plus b. So we can easily identify the slope and the y-intercept. For the slope, we have positive 3, and for the y-intercept, we have positive 2. Again, we will be using the slope and a point to graph the given equation. For 3x minus y is equal to 4, the slope is positive 3 or 3 over 1, and the y-intercept is negative 4. So, the first point that we are going to use is at 0, negative 4, and that is located along the y-axis. To find the second point of the equation, we have to consider the slope, which is positive 3 over 1. Rise is positive 3, so we have to count upward. 1, 2, 3. And the run is positive 1, that is going to the right. And now, the second point is located at positive 1, negative 1. Connecting the points, we have now the graph of 3x minus y is equal to 4. For the second equation, y is equal to 3x plus 2, the y-intercept is positive 2. Therefore, we're going to use the point 0, 2. And again, that is located along the y-axis. For the second point, we have to consider the slope, which is 3 or 3 over 1. Rise is positive 3, so we have to count positive 3 upward. 1, 2, 3. And for the run, we have positive 1, and that is going to the right. And our point now is located at 1, 5. Connecting the point, we have now the graph of y is equal to 3x plus 2. The next pair of equation is x plus 3y is equal to 6 and 2x plus 6y is equal to 12. To find the slope and intercept, we need to use the slope-intercept form. Rewriting the given, we have now 3y is equal to negative x plus 6, dividing both sides by 3. Y now is equal to negative x over 3 plus 2. And the slope of x plus 3y is equal to 6 is negative 1/3. And its y-intercept is positive 2. For 2x plus 6y is equal to 12, that will be 6y is equal to negative 2x plus 12. Divide both sides by positive 6. Y now is equal to negative x over 3 plus 2. Slope is negative 1/3 and y-intercept is positive 2. We are now ready to graph the given pair of equations. For x plus 3y is equal to 6, we're going to use the point 0, 2 because the y-intercept is 2 and that is located along the y-axis. For the second point, we have to consider the slope, which is negative 1/3. Rise is negative 1, that is downward, and the run is positive 3, which is going to the right. The second point is located at 3, 1. Connecting the points, this will now be the graph of x plus 3y is equal to 6. For 2x plus 6y is equal to 12, again, the y-intercept is positive 2. So, we're going to use the point 0, 2. And the slope is negative 1/3. Negative 1 for the rise, going downward, and positive 3 for the run, going to the right. And the second point is also located at 3, 1. Connecting the point, this will now be the graph of 2x plus 6y is equal to 12. Let us now proceed to the kinds of systems of linear equations in two variables. The first kind of system of linear equations in two variables is consistent and independent system. A system of linear equation which has only one solution if their graph intersect. Considering the slope and y-intercept of consistent and independent system, for the given 3x plus y is equal to 5 and 2x plus y is equal to 3, they have different slope and different y-intercept. The second kind of system of linear equations in two variables is inconsistent system. System of linear equation which has no solution if their graph do not intersect. Considering the equation 3x minus y is equal to 4 and y is equal to 3x plus 2 for inconsistent system, the slope is the same and the y-intercept is different. The third kind of system of linear equations in two variables is consistent and dependent system. A system of linear equation which has infinitely many solutions if their graphs coincide. For this pair of equation, x plus 3y is equal to 6 and 2x plus 6y is equal to 12, this is considered as consistent and dependent system because the slope is the same and the y-intercept is also the same. Here are the things to remember for you to easily categorize when a given system of linear equations in two variables has graphs that are parallel, intersecting, and coinciding. For consistent and independent system, slope has different value. Y-intercept can be the same or different. The graph is intersecting and solution is only one. For inconsistent system, slope has the same value. Y-intercept is different. The graph is parallel and it has no solution. And for consistent and dependent system, the slope is the same, the y-intercept is also the same. The graph is coinciding and solution is infinitely many. It's activity time! The title of the activity is consistent or inconsistent. We're going to determine whether each system of linear equations is consistent and dependent, consistent and independent, or inconsistent. For number 1, we have 2x minus y is equal to 7 and 3x minus y is equal to 5. And for number 2, we have 2x plus y is equal to negative 3 and 2x plus y is equal to 6. You are given 15 seconds to answer. Let us see if your answers are correct. For number 1, we have 2x minus y is equal to 7 and 3x minus y is equal to 5. To identify the slope and the y-intercept, we have to rewrite the given into slope-intercept form. For 2x minus y is equal to 7, we have negative y is equal to negative 2x plus 7. Multiply both sides by negative 1, y is equal to 2x minus 7. The slope is positive 2 and the y-intercept is negative 7. And for 3x minus y is equal to 5, we have negative y is equal to negative 3x plus 5. Again, we need to multiply negative 1 both sides of the equation. So y now is equal to 3x minus 5. The slope is positive 3 and the y-intercept is negative 5. Analyzing the slope and the y-intercept, we have different slope and different y-intercept, and that is consistent and independent system. Let us now proceed to item number 2. 2x plus y is equal to negative 3 and 2x plus y is equal to 6. Rewriting it into slope-intercept form, for 2x plus y is equal to negative 3, we have y is equal to negative 2x minus 3. Slope is negative 2 and y-intercept is negative 3. And for 2x plus y is equal to 6, that will now be y is equal to negative 2x plus 6. The slope is negative 2 and the y-intercept is positive 6. The slope is the same but the y-intercept is different, so that is inconsistent system. I hope you learned a lot today. Thank you for watching.